Okay, so let's look at some advanced network attack analysis, and we should be able to look at the network trace and also onto the host to be able to see our evidence of our attack traffic. Okay, so this is the network trace that we've captured. So this is analyzing the network packets across a sample network. So what we'll try and do is try and understand the basic signs of an attack, and hopefully we can pick off evidence from that. So the first thing we're going to look at is some statistics, and we'll have a look at the conversations that have been created. Okay, so we can have a look at the Ethernet traffic on the network. Okay, so this gives us a chance to see which nodes have been generating most traffic. So we can see there's this one here. Also allows us to be able to see the MAC addresses that are on the network. Along with that, we can actually have a look at other types of traffic. So this is the IPv4 traffic, and this will allow us to see the nodes which are sending, and also the ones that are receiving. And then again, we could look at the amount of traffic that's caused by each. So you can see there's a great deal of traffic that's caused between this node and this node. Okay, then we can have a look at the TCP information. This will generally show us our connections that we have, and we can have a look. We can graph them. Okay, and we can see the basic timeline of activity. Okay, so it's there that we might do a basic audit of all the systems that are on the network. Because we have so many network packets, it's quite difficult to actually mine through, so we often use the filter. So the filter will actually allow you to be able to type in a filter command and then get the information. So let's say that we wanted to look at all the ARP on the network. So the ARP is whenever one node wants to communicate with another one on the network, it will typically send an ARP. So what happens is that this node here, the node is at 192.168.0.4, sends out an ARP request for this IP address, and then in this case we can see here is a reply. So tell 0.1 who's got this address, and we can see that the machine at that address, 0.11, has replied back with its MAC address. Once the machine has the MAC address, then it can now communicate with the node. Okay, so this is all the ARP activity on the network. Okay, so what we often see with a MAC address is that for an address of this 000C296895C5, then the first 6 characters, hexadecimal characters, actually define the network card or the vendor. So there's an Intel one there, and this is a VMware one there. The other ARP address that we see is what's called the broadcast. The broadcast is sent to the whole of the network, bounded by a network gateway. So now what we'll do is we'll have a look at the connections that have been made, and we can look at the flags. TCP SYN. The TCP SYN flag is sent at the start of a connection, and this will show us all the SYN flags, all the connections that have been made here. But what it might also do is actually show us the syntax, such as these ones here. So if we only want to see the SYNs, then we can actually define our flag of an ACK equal to a 0. Okay, so here's the connections here. So the way that we look at this is the destination port is port 80, which means this is a connection to a web server. Okay, so we'll just select one at random. Let's select this one here. So this node here is communicating with this node. What we'll do is we'll follow the stream, and it should give us the details of the request. Okay, so in this case we're asking for images, and there's some other details about the request, and this is the reply that comes back. This just happens to be the reply coming back. We can actually identify JFIF is actually a sequence that identifies a JPEG. So this is the JPEG coming back. We see it has a header, HTTP header, and then there's the information there about the JPEG. It's coming back, and then it's asking for some more information from the same connection, and so on. Okay, so HTTP was meant to be just a connectionless where we connect once and get a reply back, but many browsers keep the connection open, and they'll transfer quite a few things from the one connection. Okay, so now what we'll do is we'll have a look at the DNS requests on the network. So in this case we're looking at port 53 for UDP to give us our DNS. So we'll just have a look to see some of the requests that have been made. Okay, so that's a response. Okay, so here's the response here. And let's look at this one. So there's a query for forestfurniture.co.uk. Let's follow the stream for that one. Okay, so there's the request, and then there's the reply. So the reply that comes back resolves the IP address 87.106.58.127 is the answer that's came back for that request. There it is there. Okay, sometimes what we get is a triple, 4 A's, and that returns back the IPv6 address. The next challenge, what we need to do is to be able to find out the gateway on the network. Okay, so the way we find this out is to be able to find some communications which go remotely. Okay, so this is our local network and this is a destination network. So we should find that the MAC address of the destination is equal to the MAC address of the gateway. So this address here is actually the MAC address of the gateway out of the network. So if we remember ED, then hopefully we'll be able to spot the IP address of the gateway. Okay, and there it's there. That's there, ED. So this is our gateway here, 192.168.0.11. It's the main. Sorry, we'd go back again. I think we picked off the wrong address. So we'll just have a look at the traffic again. So let's pick off some traffic here. And sorry, the destination address is 49 at the end. So if we look here and we're looking for 4.9 for the gateway, there it's there. Okay, so this is the gateway address here. Okay, so what we do is we look for the MAC address of the destination MAC address in our communications, which are for networks out with our own, and that gives us what the MAC address is, and we can actually resolve it back to an IP address. So the answer to this one is 192.168.0.1. Now what we'll do is we'll have a look at the some Nmap evidence. So one thing that Nmap does is if it's local, then we'll see a sign of a scan with ARP. And a scan with ARP looks a bit like this here. Okay, so it's a continual request on the network for a range of IP addresses to be able to resolve the MAC address. So we can see in this case that it's 0.12, which is doing the scanning. And what we should be able to spot is which machines are actually online. Okay, so if we scanned through, we should be able to see if any of these reply back, then they are online. So we'll just keep searching until we see one. There's one there. Okay, so the note that 0.13 is online just now, and now with the Nmap scan it's actually found that machine out. Okay, so now what we'll do is we'll try to find a scan of the TCP ports on a machine. So Nmap will scan a machine for the open ports. So let's see if we can detect that actually happening. Again, and the basic sign is that there'll be one single address which is continually sending out a SYN on different ports. So here we go. This is the start of our port scan across the whole network. So what we're seeing is it's found out that 3, 4, 7, 8 and 11 are online, and 1, and then it's scanning each of the ports across the network again and again on different TCP ports. So then the answer to this one is that the scan happens somewhere around here. The hosts that are being scanned are 3, 4, 7, 8, 11, 1, and the scan error is at 0.12. So now what we need to do is to be able to find out which ports are actually open . And we'll give an example. We'll give an example of this. So this was where it found out the machines that were online, and here we go here for the results. So if we just go through, then we're looking for a SYNAC to come back from one of these SYNs. So a reset ACK means the port is not open. So all we have to do is to just scroll down until we see a SYNAC, and here's one here. So this means that this port is now open. So this is the client scanner sending to 0.11 for a SYN, and we see the reply that comes back as a SYNAC. Okay, so that's one of the ports that are open, and then you can scroll down and then hopefully find other ones. with inside there to be able to tell the other ports. Here's another one. Telnet is open because there is a SYNAC coming back from our Nmap scan. We can tell that this isn't a connect scan because there is no ACK coming back to finish the connection. This is a SYN flood from Nmap because it never actually completes the connection. Next thing we'll look for is a Hydra scan. So the Hydra, we've seen that what we get is a whole lot of attempts on the FTP port for a username, different usernames and passwords. So here we go. Here, this is a sort of standard sign of users being logged in. So you can see these are the examples here. So we can search for the successful logins. We can also search for these are the logins. We can search for the login prompt, which is 220. So these are all the times that the port has been accessed for FTP, and a 230 response gives us a successful login, and a 530 gives us an unsuccessful login. So from this we can actually locate if someone is trying to fish for usernames and passwords. So let's see if we can find the first signs of our Hydra attack. We'll look for the 220, and there it is there, and then we'll just clear. In fact, we'll look for 530. Okay, so here's the sign of continual logins. So the Hydra attack happened somewhere around here. Okay, so there's the connection that we have there. And here we go. So these are all the user names that are tried. So Hydra will do them in parallel. So we keep going through it until we find the initial starting point of our Hydra scan. Here we are here. Okay, so there's the ARP just before the connection from Hydra, and at packet 26960 we see the first connection in there, followed by many other connections to FTP, because Hydra will do multiple connections at the same time. So let's have a look at some of the usernames and passwords that it's used. So we'll just start with the SYN. And here are some of the usernames and passwords: admin Napier, test Napier, and so on. Okay, so let's see if we can find the successful login. And then have a look at that. So there we go. There's a successful login there, administrator and Napier. Right, so after the intruder has cracked the username and password for Hydra what we should see is them trying to connect in again. So we'll have a look at the successful logins, which are 230. And if we assume that the first one is the Hydra attack, then the second one will be the intruder connecting in after the attack. And there we go. So this is what they've been doing. They've logged in user administrator Napier. There we go. If we look, and then we see some changing of working directories. So CWD is changing working directory to the top level. PWD is the present working directory, and so on. Okay, so the user there does a list of the folders in there, and then they go into the order folder, which doesn't seem to exist. Okay, so let's see if we can find the store command. And the store command is where a user actually puts a file onto the server. Okay, and here we go, there it's there. So these are the things, these are the files that the user has uploaded. So what we'll do is we'll see if we can have a look at this special code and to see if we can crack it. And let's go to an MD5 cracker, paste it in and see if we can crack it, and there it is, tortoise. Right, so what we're going to try and do now is to actually cross-correlate our evidence that we see on the host to what we see in the network traffic. So we just open up the host, and this is our network traffic. I'll just put this one over here. Just log in. Okay, so the trail of evidence that we see here should actually fit in with what we see on the host. Okay, so we're going to actually have a look at the FTP traffic. Okay, so let's look at 230. Okay, so the FTP traffic on the Windows server is in the inet pub folder and FTP root. Okay, so there's a directory in there, and then there's some files. Okay, so if you remember, we used this one here to be able to have a look to see some of the files that was stored, and there is one of them there. So let's actually just have a look at that stream to see how that file got there. Okay, so the user logged in, they went into the directory folder, correct? They did a present working directory, they did a passive. So passive is where the file is actually transferred. Sorry, the list, in this case, is the list that's transferred on this port. So we can calculate the connection port which is 5 times 256 plus 84, and it's transferred on port 1364, and then it opens up another passive port, and then it stores the document. Okay, and that's that document there. Okay, and then in this case the port is 1365 that it's transferred on. So we should see a network connection on those ports happening for the file to be transferred. Okay, so there's the request. And there we go. Okay, so there's the connection there, 1365. This is the first connection, and if we follow this, we should see the listing. Okay. Okay, passive. Then this is the list. This is the new port 1366 that's opened up, and there we go. And there's the listing there. Okay, so the intruder went onto the system, did a list of that folder, and there's the files that are actually in there. Okay, so if we look at our host again, we should be able to have a look at these files. Tortoise, and we might not have a Word viewer on here, but that looks like a Word document file. So the next thing we'll have a look at is the telnet accesses. So TCP port equal to 23 is our telnet port. This is all the telnet accesses. So again, what we do is we just open up the stream, and we can see what the user has been doing there. They eventually get in with administrator Napier here, and then they change the working directory to the top level. They go into inetpub, into www-root, and that's what they see. So if we have a little look in inetpub, www-root, there we go. Okay, so that's what they did there. They went into the Tor folder, which is actually a hidden folder. Okay, and if we look at what they've done, they've erased some files, and look here, they've hidden the Tor folder and then exited. Okay, so that's how we could find that, because it's a hidden folder. So we'll go into Tor, and let's see if there was anything in that folder. And there is. Okay, so what we should be able to do now is to download and delete package, and then undelete the images from here. Okay, so if you can download from the internet and undelete package, go into this folder and see if you can recover these files again. Okay, so the next thing we're going to look for is some emails. So if we wanted to look for port 25, this is the port that's used to send emails. Okay, so if we can find the send there, then we can follow the stream. Okay, and we can actually see exactly the email that was sent from the user. So this is what we see, hello, and this is the mail from and to. Then we have some data, and this is the content of the email message that was actually sent. Looks a bit strange from there, but we can actually trace the emails that were actually sent for each of these SYNs. And then we can have a look at the emails that were read. TCP.port equal to 110. Okay, so we'll just pick off one, and let's see if we can see some of the email content. Well, there's nothing in that one. But if you search through, you should be able to find the contents of the emails that were actually read. So the next thing we'll do is we'll have a look to see if we can actually detect any things like PDF documents in the packet payload. So we look for a %PDF as the magic number for a PDF file. There isn't anything in there. So let's look for a GIF file. And there's quite a lot of them. Okay, so we just open up one. We can actually have a look to see what the GIF file was. There it's there. Okay, and then when we look at the content, look, there's the magic file number there, 89A. And we can look for binary data. So if we look for HGP contains /89 x50 x 4e and x47. This is the magic number for a PNG file. So if you're interested in the magic numbers of file contents, then you should find them at this address here, Forensics Magic, and these are all the magic numbers. So if we wanted to look for a PNG, there we go, 89, 54E, 47. And that's the sequence there. Okay, so whenever we see that in network packets, there's a good chance that there's a PNG in there somewhere. And you can do the same for a zip file. We'll just search for a couple of the characters, /x4b and /x30. And there we go. So we found a zip file, hopefully. Okay, so in this way we can actually search for different types of files, different types of signatures, and so on. So if we now save our file, and I'll just save it to a folder.